Hello, this is Schedulytics and welcome to today's session. If you are new to the channel, we encourage you to subscribe to the channel and turn on the post notification bell so you are always notified whenever.
Yeah, so we are going to look at how we can use a chi-square analysis in order to tell whether an observed proportional difference between two categorical outcomes regarding a particular target outcome is statistically significant, for which reason we can make conclusions based on it and then take interventionary actions as public health personnel or even business people or even social scientists. Now, for the purpose of this video, the examples we'll be mentioning may be more related to health than to other fields of endeavors like the social sciences or finance. However, the concept that is being discussed here is very much applicable to all these spheres of life. And so feel free to apply this concept to other fields that you find yourself in. Now, we have, assuming that we have two communities, communities A and community B. You want to screen these two communities of a particular disease to see whether people have normal levels of it or abnormal level of it. Now, you realize that in community A, there are 100 people that are residing there. In community B, there are 1,000 people that are residing there. Now, after running your screening, you realize that the abnormal levels in community A was found among 20 people. And then in community B was found among 25 people. Gauging by the figures, one can tell that community B is having more abnormal levels compared to community B. And maybe judging from those figures, one can just go ahead to render interventions for community B relative to community A. But is that really the situation? Now, there's the need for us to fall on the proportional difference, where we are going to look at the ratio of those who have the disease relative to the total population present in that particular community. So in community A, we can say there's 20% rate of infection, whilst in community B, I think it's about 2.5%. So looking at 2.5% and then 20%, which one is bigger? Now, scientists will not just look at those proportions and then make conclusions. No, they will need to test. They will need to design or develop a hypothesis and test that hypothesis. So assuming that there's no difference in the proportions, and then the alternative will become there is a difference in the proportion. So we use a chi-square and then agreeing that our confidence interval should be 95, margin of error 5%. Then we can see when our p-value is less than 0.05 or 5%, we can reject our null hypothesis and see that the difference is significant, or there's a difference in the proportions. However, if the p-value is greater than 0.05 or 5%, then we can say that our null hypothesis cannot be rejected. So we fail to reject it and see that there's no difference in the proportions. So basically, that is the concept of the chi-square. So we want to go to SPSS and see how we can do the chi-square analysis using the SPSS platform. So here we are going to see the levels of this particular normal level and abnormal level among people living in a location called community A and then community B. So we'll go to analyze as usual, and then we'll come to descriptive statistics. Then we'll click on crosstabs. So immediately you click on crosstabs. Immediately we click on crosstab, we select our location and bring it there. Initially, it will not be there. It will be empty as you can find it here. So you have to select it and move it there, and also come here and select it and move it there. So the particular variable you want to do the cross tabulations with your chi-square analysis for, you select the two. Now you come to statistics and check chi-square. chi-square at the top here. Then you press continue. Then you can press the cells and then check the observed and expected counts, as well as the row and the column percentages. Now, there's a reason for which you need to know the expected. Now, when you look at the mathematical formula or basis for the chi-square analysis, you realize that there is some complicated calculations from expected minus observed and so many stuff. So there's the need for us to use this expected. And mind you, when it comes to running this on the statistical software, we have to know our expected values because it will inform us as to whether we should use the chi-square or we should fall for the Fisher's exact. So it's also a reason why you should be able to check it. Now, the outcome will tell us we have run that. So let's go to the outcome and see how it is more meaningful. So let's go to the outcome and check to see why it's very important we run the expected outcome, and then we can see why it will help us to make a decision as to selecting the Fisher's exact or the chi-square. Well, so the outcome says that for community A, the total number of people here are 63. For community B, the total number of people are 78. Obviously, community B is more populated than community A. So although the count of abnormal here is 39 and that of community B is 48, 48 is obviously bigger than 39. But then when it comes to the proportion within the location proportion, 61.9% is greater than 61.5%. So the proportion wise, we have community A having greater than community B. Now we'll now come to the chi-square or the significant level, the p-value. And obviously this 0.695, which is far greater. 0.965 is far greater than 0.05%. And so what it means is that we fail to reject our null hypothesis that there's no difference in the proportions. So actually, these proportional differences we have observed here is actually not statistically significant or different. And so we can't make any conclusions on it. Now you see the bottom here, the A cells are expected to be expected count less than 5%. So let's run a situation where we'll have the expected counts being less than 5% and see what it will tell us to use. So we are just going to use this and then we click on OK. Great. So here you can see the expected out counts here. So this is 61 point, this one, and 1.8, 75.8 and 2.2. When you go up a little, let's go back to what we did last time, the previous time. These are the expected. You realize that the least expected outcome was what? 24.1. But when we come to this one, for example, that we just run, our expected is 1.8. So down here, it says that 2 cells have expected count less than 5. So when we have expected count less than 5, then our choice of test statistic is no longer chi-square, but Fisher's exact. So in that case, we would go for the Fisher's exact rather than the chi-square. So this is also a key reason why you should run your expected counts in addition to your observed count, so that you can be able to make informed decision as to whether you are settling for the chi-square or the Fisher's exact test. Or if you like content such as this, we encourage you to subscribe to the channel, turn on the post notification bell so you are always notified whenever we release a new video. Like and share. Until we meet again, thanks for watching. Say bye.